Okay, so the lesson for today, we're going to be going over 5.1, which is a new lesson for us. It's all about trig identities. So in class today, I guess I'm recording today, you guys are watching tomorrow. So in class yesterday, we talked about the quotient identities, the Pythagorean identities, and the reciprocal identities. So all of these identities are kind of like a review. We've already gone over them. And we're going to talk about how can we use them to find real solutions. So first question, this is kind of a review, but I want to use the fundamental trig identities. I want to evaluate cosecant of u is equal to negative 5/4. If tangent of u is greater than 0, find all 6 trig functions. Okay, well, to find the 6 trig functions, let's go ahead and list them. I know cosecant, so cosecant's one that I already know. Move this totally my way. Cosecant's one that I already know. So there's cosecant of x is equal to negative 5/4. I know that one. If I know cosecant of x by reciprocal identities, I already know what sine x is. It's the reciprocal, so it's negative 4/5. So really, I only need to find 4 other trig functions. So let's go ahead and draw a triangle because I don't know what negative 5/5 is on my unit circle, but I can draw a triangle to figure it out. So I'm going to go ahead and draw a triangle. So using this bow tie method, so using triangles that are in the shape of a bow tie, let's go ahead and determine which triangle it's going to be. Well, if I remember what cosecant is equal to r over x, or over y. So it's the reciprocal of sine. Sine is y over r, so cosecant's r over y. Well, that means there's 2 options. Either it's negative 5 over 4, or it's 5 over negative 4. Now, here's a little fun fact here. Radius cannot be negative. So the radius is a distance on my triangle, and distance is not negative. So your radius is always positive. So basically it has to be this one here. So I know right now that my radius is going to be 5 and my x value is negative 4. So that tells me, if I graph this in red, that tells me I need to go to the left 4. Well, that leaves me 2 triangles, the triangle in the second quadrant and a triangle in the third quadrant. We know one more piece of information. I know that tangent of u is greater than 0. So if I go back to all students take calculus, where is tangent greater than 0? Well, at the t for tangent is greater than 0 in the first quadrant and the third. So we're going to go ahead and use this triangle as our reference. All right, so I know that this is going to be negative 4, and this is going to be 5. And if I just kind of remember, I guess, Pythagorean triples, this would also be 3 here. It's a 3, 4, 5. You could also prove it by saying negative 4 squared plus b squared is equal to 5 squared, and you would see that b is equal to 3. Well, at this point, we know everything we need to know to find the rest of the trig functions. So let's go and find them. If I want to find tangent of x, well, tangent of x is equal to opposite over adjacent. It's also equal to y over x. So looking at my triangle, let's find out what y over x is, or opposite over adjacent. That's going to be 3 over 5. So tangent of x is equal to 3 over 5. Well, cotangent is just the reciprocal, so I really don't have to do any work there. Cotangent is going to be 5/3, the reciprocal. Last one, we already know sine of x. Let's find cosine of x. To find cosine of x is equal to adjacent over hypotenuse. It's also equal to x over r. Well, in this case, x over r is going to be negative 4 over 5, or adjacent over hypotenuse is still negative 4 over 5. Well, to find its reciprocal secant, all I need to do is flip the numerator and the denominator. So I'm going to get 5 over negative 4. So these right here are all of my solutions for the trig functions if I know that cosecant is equal to negative 5/4 and tangent is greater than 0. Okay, so that was kind of a review. We've actually kind of done questions like these before, so let's keep on going. Using fundamental trig functions, I also want to learn how to simplify. So this is part of our goal for the day. In order to simplify these, really what I want to do is just see if I can condense them anymore, if I can rewrite them as something else. Traditionally on a test, I would give you the end result and tell you, hey, can you prove that this expression here is equal to another expression using the identities? So let's go ahead and start this one. Sine of theta, secant of theta all over cosine squared theta. Well, I know that secant of theta is the same thing as 1 over cosine of theta. So I'm going to go ahead and write that. We're going to say that this is sine theta times 1 over cosine of theta, all divided by cosine squared theta. Well, sine theta times 1 over cosine theta is the same thing as sine of theta divided by cosine of theta, and then we say that this is still all divided by cosine squared theta. Sine theta divided by cosine theta, that really rings a bell. Isn't that tangent? I have no one to answer that question, but the answer is yes, that is tangent. So this is going to be tangent of theta divided by cosine squared theta. If I want to rewrite this again, this is the same thing as me saying tangent of theta times 1 over cosine squared theta. Cosine, if cosine's in the denominator and I have 1 in the numerator, if I go back to my reciprocal identities for a minute, I know using a reciprocal identity that cosine, that secant, is the same thing as 1 over cosine. So I can actually rewrite this as secant squared. This is the same thing. So I can write this as tangent of theta times secant squared theta. So like on a test or quiz, I might say, hey, start here, get here. That's really what I'm asking. All right, second piece, what happens if I have addition of trig functions that have fractions? Well, it works the same as any fraction. If you want to add a fraction, make sure the denominator is the same. The denominator is the same here, so I'm going to have sine squared theta plus cosine squared theta all over cosine. Well, if I think back to my Pythagorean identities here, sine squared theta plus cosine squared theta, if you go back, is equal to 1. So I'm going to rewrite this as 1 over cosine theta. Using a reciprocal identity, 1 over cosine theta is equal to secant theta. And so this right here is the simplified solution. So on a test or quiz, I might ask you, hey, start here and get here. All right, let's move on to the next problem. All right, so the next problem says factor each trig function. So I know that these look kind of crazy, but what I want you to think about is this. Think about it in terms of, go back to your 3rd grade brain for a minute. So if I was just in 3rd grade and I kind of just learned how to like master reading a little bit, looking at this expression right here, what are some symbols that I see in common? What are some common phrases, some of the similar words? Well, if I looked at this with my 3rd grade brain, I might see that this looks the same as this, maybe. These two things look the same. Well, if these two things look the same using my 3rd grade brain, let's go ahead and go back to our Precalc brain. That must be a common factor. It looks like sine squared x and sine squared x are both in the expression, which means they're a common factor. I'm going to take it out. So I'm going to factor out sine squared x. If I factor out sine squared x, what's left in the inside is secant squared x minus, well, if I took a sine squared x out, what's left is 1. In essence, I divided everything by sine squared x. So real quick, I want to still simplify this. Secant squared x minus 1 looks kind of familiar, maybe not totally, but let's go back to the Pythagorean identities. Squared x, if I move the 1 over to both sides, then I actually get that tangent squared x is equal to secant squared x minus 1, which is what I have in that original expression. So if I go back here, I have secant squared x minus 1. Well, I know by Pythagorean identity that that's got to be tangent squared x. So I could actually rewrite this total function as the following. I could write it as sine squared x times tangent squared x. Okay? For this last one here, what I might do, so I think this will probably be the last one we leave off on. What I want to do is I want to go ahead and use properties of fractions to kind of split this up into 2 pieces. So cosine of x all over minus 2 all over cosine squared x, I want to combine it with 4. Well, in order to add or subtract these things, I need to have a common denominator. So really what I need is I need this denominator to be cosine squared x. That's pretty much all that we have time for today. I'm about to expire on this